All right, here we go. So let's read the directions here and take a look at what we have. All right, if you remember, these dotted lines are like the second lines that we did. This is how we decomposed it. This is us making the rows in that array. So the shaded fractions have been decomposed into smaller units, okay? Express the equivalent fractions in a number sentence using multiplication. The first one's been done for us. So let's take a closer look at number one, okay? So, number one, the original fraction, if I can just pretend that this dotted line is not even there, was 2/3. See that? 2/3. If I just look at this, without that dotted line, I'd have 3 spaces with 2 of them shaded in. Then what they did is they made 2 rows out of it. Instead of one big row, they made 2 rows. So to do that, they put this in here and decomposed these thirds down into 6. See this? 1, 2, 3, 4, 5, 6. So they multiplied it by 2. 1, 2. See that? Okay. Let's move on to B over here and see if we can break this down. Okay. Now the original fraction here. Now with your mind's eye, take out those dotted lines, and we're just going to count the columns across. You ready? Count with me. 1, 2, 3, 4. So originally, this model was fourths, and 3 of them were shaded in. Then what did they do? Then they made these 2 cuts across here to make 3 rows. So basically, they went from 1 big row to 3 rows. See that? So they multiplied 3/4, okay, both the numerator and denominator by 3. And what did we end up with? We're going to end up with 3 times 3 is 9, and 4 times 3 is 12. So let's count. Let's count the shaded, or let's count all of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's my 12ths. Then the shaded area. 1, 2, 3, 4, 5, 6, 7, 8, 9. Good. Notice I didn't add any more shaded. The shaded area is made exactly the same. We just cut this down into smaller pieces. That's all. Okay? So we went from fourths to 12ths. Let's click down here. Right. So originally this fraction, what was it? So if we pretend that that dotted line is not there and we just count the columns, okay? 1, 2, 3, 4, 5. This originally was cut into fifths. So that's my denominator. And 4 of them were shaded. So it was originally 4/5. Then someone came along and decomposed it. They broke it down from fifths, they broke it down into smaller pieces. So instead of just 1 big row, they made it 2 rows. So they put this line in, decomposed it. So they multiplied both the numerator and denominator by 2. And what did they end up with? 8. 4 times 2 is 8. 5 times 2 is 10. They end up with 8/10. Now you can see the pieces went from being pretty big to a lot smaller, okay? But those fractions are the same. 4/5 and 8/10 are exactly the same amount. All right, moving on to this one. This is D. All right, before they put this dotted line in, before they decomposed it, they just had the columns, and it was just 1 row. So we're going to count. 1, 2, 3, 4, 5, 6. This was in sixths. And how many were shaded? 1, 2, 3, 4, 5. Great. Then, what did they do? They took that 5/6 and they multiplied it. Okay, they decomposed it down into 2 rows. See that? 1 row, 2 rows. So they multiplied all of this by 2. So 5 times 2, that'd be 10. And 6 times 2 would be 12. So let's check to see if that works. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's my 12ths. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 12ths. 10 are shaded in. So 5/6 is equal to 10/12. All right, I hope you're having fun. And again, teachers, pause, explain, use the whiteboards if you need to. Get it out and go over this the best you can, all right? Now we're going to keep moving though. All right, here we go. Zoom back out a little bit. Move this up so we can see a little bit better. And then read. Decompose the shaded fractions into smaller units as given below. Express the equivalent fractions in a number sentence using multiplication. Okay, so this part is the same as doing this part, except that they didn't give us this dotted line. We have to do that, okay? So let's take a look. Let's zoom in on this guy. There. So we got to decompose this into tenths. So let's figure out what fraction this is first, okay? Let's count the total number of parts. 1, 2, 3, 4, 5 parts. See that? It's 5 parts. It's one row of 5 parts. So I've got fifths. Well, how many are shaded in? 1, 2, 3. It's 3/5. Okay. So now it wants me to make this into tenths. I can do that. So to make it into tenths, I'm going to write that over here, tenths. Okay. How do I get 5 to turn into 10 through multiplication? Like what times 5 is equal to 10? So what needs to go there? What times 5 is equal to 10? The answer is 2, isn't it? Yeah. If I multiply the denominator by 2, I must multiply the numerator by 2. And that gives me 6/10. So what did I do here? Since I multiplied by 2, instead of having just one row, I need to have 2 rows. All right, so I just make a cut right across the middle. Now I've got 2 rows. See that? And now I've got tenths. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And now, instead of having just 3/5, I have 6/10. Smaller pieces, of course, right? But the same amount. 3/5 is equivalent to 6/10. All right. Let's move on to this one. Decompose into 15ths. That's a lot. 15ths. It's a good thing we're wearing masks. Okay, so let's see what fraction we have first. 1, 2, 3, 4, 5. That's fifths. I've got a lot of room over here, so I'm going to write over here, okay? Excuse me. Fifths. 1, 2, 3 of them shaded in. 3/5. Cool. I need to make this into 15ths. All right, so over here, you see I'm going to make some space. I need to make this into 15ths. So I need to ask myself, well, geez, what times 5 is going to give me 15? Right, let's count. 5, 10, 15. There's 3. Right, if I multiply the denominator by 3, I must multiply the numerator by 3. 3 times 3 is 9. So 9/15. So let's check on our model, see if we can do that. So see here, I multiplied by 3. So instead of having one big row, I need to have 3 rows going across. And if you remember, 3 here, I need to have 2 cuts. 1, 2. That gives me three rows, just like that, okay? And if I count, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. There's my 15ths, much smaller than fifths. But now I've got 9/15 instead of 3/5, which is the same exact amount. 3/5 is equivalent to 9/15. Okay. Last page here, okay? So now it tells me to draw area models to prove the following number sentences are true. All right? I think I can do that. So let's take a look here at the front. All right, zoom in. 2/5 to 4/10. So the first thing I need to do is draw 2/5. So let's do that. So I'm going to draw a rectangle. It's like that. Rectangles are the best to draw for fractions. Now I need to cut this into fifths. Now there's no easy way to do this, so I'm just going to show you, okay? Let me zoom in and show you how I do this. I know I need 4 cuts, okay? And 5 is not an even number, so I can't split it in half. So I need to make 4 cuts. It needs to look like this. 1, 2, 3, 4. Just kind of freehand. You see the little tick marks? Those are easy enough to erase if I'm off. But I like that spacing, and if I count the spaces, 1, 2, 3, 4, 5, there's 5 spaces, which is my fifths. So now I can just drag my lines down to the bottom like that, and I have fifths. Great, just like this one asked me to. Now I need to shade in 2 of them. So 1, 2/5, just like that. Now it wants me to go from fifths to tenths. So I have to ask myself, what times 5 is 10? Right? The answer for that is 2. 5 times 2 is 10. It also works up top. 2 times 2 is 4. So I need to make 2 rows here. In order to make 2 rows, I just cut that right in half right across. And now I've got 2 rows. Now check it out. I went from fifths to tenths. Smaller pieces, of course, right? But 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And there's 4 of them shaded in. There's 4 tenths. So I went from 2/5 to 4 tenths. Neat, right? All right. Got to keep practicing. So I need to go from 2/3 to 8/12. Okay. So let's draw 2/3. So we're going to draw a rectangle. And I'm going to draw thirds. Okay, that's my original fraction here. Let me get centered here. Great. So thirds, 2 cuts. 1, 2. Good. So I'm going to take those down and shade in 2. 1, 2. Good. Now I need to make it to 12ths. So I need to ask myself, what times 3 is 12? Or I could just count by 3s. I could go 3, 6, 9, 12. Look at that. 4 3s. So I know that 3 times 4 is 12, which means I have to go from 1 row to 4 rows. Now 4 is an even number, so I 3 cuts. 1 right down the middle here. And then I can cut that top one and then this one here. And I get nice 1, 2, 3, 4 rows, which gives me 12s and 8 of them are shaded. Okay? That one's done. Let's check out this one. C. Okay. 3, 6 to 6/12. So let's do this one first. 3/6. Okay, so let's break this into 6. 6 is an even number, so I can cut it right in half. Now I need 3 and 3, right? So I gotta do, there's 3. And then I gotta do, there's 3. So 5 cuts all together. So let's count. 1, 2, 3, 4, 5, 6. Good. Now 3, 6. Shade the 3 in. Just like that. Now I need to make it into 12ths. So what times 6 is 12? You guessed it, it's 2. So I need to make 2 rows here by cutting this right down the middle. So I got 2 rows. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12ths. Right there, see that? So this is 6/12. Same or equivalent to 3/6, okay? Let's check this out. All right, 4/6 to 8/12. Same exact thing, except I'm gonna a little bit more. So cut this into 6. All right, another way you could do this, before I showed you split it in half and then thirds, I could split this into thirds, like that, and then cut each of those in half, and you get 1, 2, 3, 4, 5, 6. See that? 4, 6. 1, 2, 3, 4. And then I need to get to 12. So I know that 2 times 6 is 12, so I need 2 rows here. There. And that makes 12ths, and 1, 2, 3, 4, 5, 6, 7, 8 of them. Okay, 8/12. Good. I'm going to zoom out. And then we're right here in the home stretch, okay? So this that says here, use multiplication to find equivalent fractions for each below. All right, so now this is basically without drawing anything. So we're going to look here at 3/4. Okay? And I'm just going to show you this one, and then teachers, you can take over for the rest of this. Okay, here. Okay? And then we're going to jump down to the one below. So 3/4. What I need to do is I can decide to make that equivalent to anything. I can make it into any factor or multiple of 4. Any multiple of 4. I can make it into 8ths, 12ths, 16ths, whatever I want to. So if I want to make this into twelfths, I need to say, all right, 3/4. So I need to multiply the top and the bottom by the same number, any number. You want to make it 3? Let's just multiply these by 3. 3 times 3 is 9. 4 times 3 is 12. So 3/4 is equal to 9/12. As long as I multiply both the numerator and denominator by the same number, I'm going to end up with equivalent fractions. No doubt. Okay? I lied, I'll do one more. Okay, this is fun for me. So 4/5. Okay, so I'm going to take 4/5 and I'm going to choose a number to multiply by. Right? Let's multiply, let's say, by 5. So, what is 4 times 5? Right? That's 20. What is 5 times 5? 25. So I end up with this crazy fraction of 20/25. Isn't that funny? All right, now I'm going to keep going because I feel like it. Now 7/6, I'm sorry. You might look at this fraction and say, wow, that looks odd. The big number's on top, and that's okay. It's a fraction that's greater than 1. Okay, it's a fraction that's greater than 1. These are okay to have, okay? Sometimes I know that if I order 2 pizzas and someone eat and they're cut into eighths, I'll have a bunch of eighths. And if, you know, so if I have pizza left over, I could have a full pizza and 2 slices, right? Which makes it 10/8, you know? So here, I could do this. It's the same exact thing. I can say 7/6, and I decide to multiply by a number, and I'm going to come up with something equivalent to that. Let's just say 2 in this case. 7 times 2 is 14. 6 times 2 is 12. 14/12 is equivalent to that, okay? All right, so let's move on to the bottom one because we're running out of time. It says, determine which of the following are true number sentences. Correct those that are false by changing the right-hand side of the number sentence, okay? So we got to find out which ones are true. So let's take a look. Here, 4/3 to 8/9. Is that okay? Now, the answer is no. This is false. And I'll show you why. What times 3 is 9? That's 3, right? So if I multiplied this by 3 to get 9, I also have to multiply the 4 by 3. And guess what? 4 times 3 is not 8. 2 times 4 is 8. So we need to correct this, okay? Let's do 4/3, and let's multiply them by the same number. Let's just choose 2. So long as it's 2. 4 times 2 is 8, and 3 times 2 is 6. Now that is better. 4/3 is equal to 8/6, okay? Check out this one. 4/5 is equal to 8/10. Okay, let's check it. What times 5 is 10? It's 2, right? All right, so 4 times 2 is 8. Well, this one's true. That one works, so we'll say true. Okay, how about down here? 4 times a number is 12. 4 times 3, right? Yeah. So 5 times 3 is, it's not 10. It's 15. So this one's false. They didn't multiply both the top and the bottom by the same number. So 4/5 is equal to 4/5 times 3 times 3. Must multiply both the numerator and denominator by the same number. You have to do it to find equivalent fractions. You're going to end up with 12/15. Okay? And then finally our last one here. 4/6 is equal to 12/18. Let's see. What 4 times 3 is 12, so 6 times 3 is 18. Oh, that's true. Good. All right, so that's our lesson for today. I hope that you had fun. I hope you had success on it, all right? We never did this one, okay? Hopefully you can do that as a class or figure that out, okay? And that's all for today. Now, hopefully tomorrow you can remember how to do this and kind of move forward with it, all right? We're talking about equivalent fractions and finding them through multiplication. Tomorrow, it's going to be a little bit different as finding them through division. So it's kind of going a little bit opposite of what we were doing, okay? All right, kids, great job today. We'll see you tomorrow.